This video is about re-expressing data. So here I have the diameter of a tree and its age, and the assumption that would be that we could predict a tree's age from its diameter. Otherwise we have to cut it down, and maybe that's not what we want to do. So I'm going to drag down a graph, and I'm going to see how age responds to diameter. And if I did put a least squares line in, and then I checked the residual plot, I would notice that there's a curvature to it, so I might not have, this doesn't look that bad actually, but we'll just go along with it, that there is some curvature to it, perhaps. So maybe there's a better way to predict age from diameter. Maybe it's not a perfectly linear relationship. So I might try something like, if you think about it, really it might not be so much the diameter as the cross-sectional area of the tree. So I'm going to try to take the square root of age. And I'm going to edit that formula, and I'm going to do square root of age and see what happens if I do that. Now I get a much better relationship. We've been doing quite a bit of logs, or we did the one example, you guys did it for exercises of reciprocal with gas mileage instead of gallons per mile versus weight, or instead of miles per gallon versus weight, you did gallons per mile. So there's all kinds of different relationships that you can try to re-express. A lot of it depends on what you think the relationship is between the two variables that you're looking at, which is what I talk about in the quiz. You're looking at the width of a deck versus its cost, what might make more sense. So anyway, now, and I'm not going to be able to do this on the video, but now you have square root of age is 0.258 times the diameter plus 1.8. So if I gave you a diameter of, say, remember we wouldn't want to extrapolate because that could be dangerous. Who knows? A tree might start to grow slower and slower the older it gets, so this model might only be useful for a certain amount of time. Extrapolation you should be cautious about, but suppose I wanted to find the age of a tree that had a 9-inch diameter. I think this is in inches. So if you plugged a 9 in for diameter, I don't know, let's say 9 times 0.25, if I had 9 quarters, that would be $1.75 plus 1.8 would be about 3. What did I say? 175, 3.5. Remember, that would be the square root of the age is equal to 3.5. So then I'd have to square both sides. So the age of the tree would be about 9 plus, I don't know, 10, 11, whatever. So the point is that when you can use this linear formula, but don't forget that you have to undo the square root part. Undoing square roots is a lot easier than logs. You guys were getting pretty good at logs when we were doing that. So plot your data, play around with what other re-expressions might work. I mean, something I could have done here was I could have tried to square the diameter. I'm going to call it d squared, and then edit that formula. And I'm going to do diameter, squared. And if I had put age here and d squared there, again, not a bad re-expression. It might actually work the same way. And in this case, all you would have to do is put in your diameter, square it, multiply it by the coefficient, and then add the constant. And then you would get the age. Anyway, that's re-expression. Give that a try. And let me know if you have any other questions.